Hello there, we're coming right back at you with the combination sum. It is another backtracking problem. It's very similar to subsets, but there's a little difference that makes it more special. So this is our 72nd video. Okay, very good. And as you can see here already, I have a bunch of numbers and what's going to happen. So very similar to our previous problem, subsets, where we're trying to choose one item and not choose another item. In this particular problem, we're doing the same, but we can reuse the same integer twice, or 3 times, or 4 times, infinite number of times. So we're going to either choose 2, or we're going to choose to move on from 2, and choose either a 3, a 6, or a 7, and basically that means we're only going to choose 3s, and then we're only going to choose 6s, and then we're going to choose 7s, and tack those on. So as you can see the output here, we have a 2, 2, 2, 3, 2, 2, 6, 2, 2, 7, 2, 2, 2, and so on and so forth, until we finally either get over 7, or we hit 7, or we run out of items to go through. And once we finish up with the 2s, we then go on to the 3s. You see a single 2, and then you see all the 3s come afterwards. And then you see the 3s, and then you see the 6s, and then you see the 7s. So basically, we're choosing 2, or we're choosing anything else, 3, 6, 7. We're choosing 2 2s, and then everything else, 3, 6, 7. And training 3 2s, everything else. 4 2s, that's over our target of 7, it's over. So that's how we're doing this particular problem. It's very similar to our previous problem, very similar. So we're creating the same subsets, and we're creating the same DFS call, but this time we have a current sum, so that we can quickly glance at what our current sum is and see if we should add this to our our items, or what we're gonna do is just move on because it's over. So else if current I is greater than or equal to the length of candidates. So either that, or our current sum is greater than targets, then return. So both these cases return. Else, that means we're under our target, and what we're gonna do is we're gonna tack on our number. So to do that, a subset dot append our current number, which is candidate I, and we're going to append that, and we're going to call it the DFS call again, similar to previously. We're going to still keep the I this time, and we're going to increase our sum. So current sum plus candidate I. And then afterwards, similar to our previous problem, let's start skipping items. So subset.pop. So that's how we pop off the items that we don't need anymore. Say, suppose these 3 2s, so we can pop off our 2, or 3, or 6, or 7. We just we return, and we pop that off, and we have 3 2s, and we reach the end. And so DFS I plus 1. So that means that now, after popping everything off, we have this 2, and 2, and 3. What happens here is, after popping it off, we still have, we're starting at 3, 6, or 7. As you can see, 3, 6, or 7. And now we can add these items into our list, so of items. So we add, try 3, we pop that off, it's too much. We we tried to append, see that we append, and then we added, and it was too much, so we pop it off. We try the next one, append, try it again, then try it again. So as you can see, the DFS I plus 1, I plus 1, I plus 1, and they all pop off, right? And then we end up with another pop to 2 2s, and then we try 2 3s because we reached the end of our eyes. Right. Anyways, as you can see this pattern happening, and so with that, I believe with this getting the item and removing the item, so on and so forth, we are complete. Our items are complete now, and we just return DFS call 0 and 0. So we start with 0. The current sum is 0, and our we start with the 0th index. Then we return the result. Let's run the code, see if we made any mistakes, and then we submit. As you can see, this works pretty well, and we solved this problem. It was a very good problem to solve because it plays on our understanding of how to do a backtracking and conditions at which we can resolve or backtrack some more. This is a good problem to do. I think I recommend it to do more and to get a better pattern recognition about this particular pattern called backtracking. There's so much more to learn, so much more to do. Thank you very much for watching. If you enjoyed the video, like and subscribe. And if you have any questions, please comment below. Oh yeah, the O of n time. O of n time is, I recall it was, we're gonna do each item until target, or yeah. Anyways, so that's basically the smallest item that's how long the tree is going to be, times n, which is the copy. So yeah, and yeah, we'll see you in the next one. Thank you.